So yun na nga mga ka-diffcalc. Since we've finished discussing all about the extreme value of a function, we now proceed with optimization and related rates. So when we say optimization, this is the process of finding the optimal values of a certain equation or a problem in which we're considering all the constraints and restrictions based on the problem itself. Okay? And when we say optimal value, we're referring to either the maximum or the minimum value of a certain variable. Now there are some few general steps in which we can solve for the optimal value of a certain equation or problem. So number one, we need to determine the variables and the constants. Knowing the variables and the constants in the problem is very important in order to solve such optimization problem, because the idea lies on knowing these variables that affect the problem set by the constants or these values that cannot be changed. And then for number two, we have to know the constraints. Knowing the constraints in optimization is a very essential thing to do, because this limits all our equations and all the boundaries of our equations. Because if we are to limit the solution of our equation, then we can find the exact or the values that we need in order to solve for the problem. For example, if you are required to determine the volume of a certain material, and then you set a constraint. For example, the constraint would be that if you take the area that is just equal to 500. So in that case, we're limiting the solution, but these restrictions would actually lead us to the solution of the problem. So that's number two. The third one is to set up the general equation. So when we set up the general equation, we need to understand that this equation should contain all the variables necessary to solve the problem. And these variables would give us the general equation in which we can relate these variables with the constants, and knowing that these constants and restrictions are stated in just one equation, then these restrictions can be represented as a function of the variable that is unknown. For example, if we need to find, again, the volume of a certain material, and then the dimensions can be represented in a way that, for example, you have a radius, and then the other dimension, let's say height, can be represented in terms of radius. So if you set up a general equation, you can now represent all of these equations in terms of radius. So if you can do that, then you will be left out with just one variable. And then we proceed with differentiation, setting it equal to 0. And then at that point, we can determine the critical value, which will lead us to determining if it's either a maximum or a minimum, or it's neither of the two. Okay, so those are the basic things that we need to understand in optimization. And I know that sometimes it's more difficult to understand that by just listening or by just words. So let's try to solve problems regarding optimization. Now we will start solving optimization problems, and here is an example of a very simple problem involving optimization. And for now, we'll be computing for the distances in a certain graph of a function with respect to a certain point and the Cartesian coordinate system. So, I forgot to mention dun sa introduction natin na we also need to illustrate the problem if possible. Now, there are times naman na hindi pwede, pero it is best to illustrate such problems, especially when it is a graph or a plot or it is a figure, para mas maidi tayo kung paano ba natin to aatakihin yung mga problems. Okay? So, before we do that, let's have this muna. And we have here a parabola, x squared minus 3x plus y equals 7, and then negative 1, 1 yung point na outside sa parabola na we need to find the nearest point din dun sa ating parabola. Okay. So with this, let's graph a parabola. So just a quick review muna, no, bago tayo mag-start mag-drawing or plot ng or mag-graph. In this topic, we'll be discussing all about analytic geometry. Medyo madaming ganon. Especially when we're looking for the distance of a certain graph with respect to a certain point or 2 points or anything, any condition. And in those cases, you have to have a good background in analytic geometry. And before I start solving yung mga problems, I'll give a quick review of yung gagamitin natin na graph. Pero syempre, I will not be digging deeper into those graphs, syempre, kasi yun naman ay review lang. So, I'll just be giving quick review and then I'll proceed with the computation. Okay? So, when we talk about parabola, and then knowing na, di ba, x squared ito. So, for every y value, there are two values of x's. So, I know for sure na this either opens upward or downward. Now, if it has y squared and then x lang itong the rest of the variables, then I know for sure that it can either be opening to the right or opening to the left. So, yun lang naman yung need natin na tandaan dun sa opening and sa opening ng ating parabola. And then, syempre, sa parabola, we know that the most important point sa parabola para mag-graph natin siya is yung ating tinatawag na vertex. And to do that, I'll be solving for this and complete the square dun sa hindi kompleto para magawa natin siya na y as a function of f squared, of x squared. So in this case, I have, let's use color blue. So I have x squared and then minus 3x plus y equals 7. So I'll be transposing this y at the right side, right side, so that will be 7 minus y, and then this is equal to x squared minus 3x. And we know that when we express a parabola, we should be rewriting this as if it's positive y and then equal to something. Syempre, the rest is x. So I'll be rewriting this into negative y plus 7 is equal to x squared minus 3x. And then, of course, this one is x squared, so I'll need to complete the square. So we have negative y plus 7 equal to x squared minus 3x, and that's 3 over 2. Then squared, so we have 9 over 4. So, since nag-add tayo na 9 over 4 dito sa right, we also add 9 over 4 sa left natin para wala tayong ginawa dun sa equation natin. And then we add those terms na pwede nating pag-addin dito. So, that's 9 over 4 plus 7. So, we get 37 over 4. So, for the right side, we can express now these in terms of x minus 3 halves square. Okay? So, finally, I will be multiplying both sides by negative 1 so that I can have positive y right here, and then minus 37 over 4, and then that is equal to negative of x minus 3 halves, and then we got square. Okay, so this is the standard form of our parabola, and so this is the general form of our parabola, opening downwards kasi negative to, and then with ascent at a vertex, with a vertex at 3 halves, and then 37 over 4. So positive sila kasi since this is x minus 3 halves, so if you set that equal to 0, then makukuha natin yung values ng ating x and y for the vertex. So, bakit ko ba ginawa to? No? So, the reason is that this is not necessary to do, especially when you want to solve for the parabola or the shortest distance. Kasi, we don't actually have to find the vertices for each of them, but this will be very helpful for you when visualizing what will happen when you take on the point here, and then you would find the distance to a certain point of the parabola from this point. So now I'll be plotting it on the Cartesian coordinate. So I hope na may gawa natin siya ng napakagandang graph. So hopefully I gave justice to the graph. And then negative 1, 1. So yun yung isang point natin of concern. So a negative 1 is around here, and then ito yung 1. So basically ito yung point na yun. So that is negative. This is let's just write it here, negative 1, 1. Okay? So, yung negative 1, 1, hindi siya belong dun sa graph natin. Kung mapapansin, lumampas siya. Pero, syempre, itong graph na to is, I couldn't say na ganito talaga yung itsura niya. I know for sure na downward siya, pero, hindi ko alam kung na-hit ko yung mga tamang points. But, the idea is something like this. Okay? And, we need to find that short distance dito. So, basically, ito yung tinutukoy niyang distance. So, I'll make it green. So, this is that distance. Okay? Ayun. Perpendicular distance lagi tayo. So, if we would zoom that, ito siya. So, ito yung parang parabola natin, and then ito yung point. So, I'm looking for this distance, and that's perpendicular with that graph. Okay? So, we know for sure na dun sa point na to, which is, let's make this red. Yan. Okay, so diba, itong point na to, in the graph, we know that we can represent that as xy point. And then we know that this point is negative 1, 1. Okay, so basically, if we need the distance, then I think you already know the step 1, as I said before, yun nga yung identify natin yung variable tsaka constant. So, in this case, yung variable natin is yung distance kasi yun yung hinahanap natin. And then, yung ating constant is this point kasi siya ay fixed. Okay. Then, pangalawa natin is to identify the constraints. And then, yung constraint natin na tinatawag is kung ano ba yung maglilimit sa solution natin. And the constraint is actually the parabola itself. Kasi, dyan lang natin makukuha yung point na yun. So, that's our limiting factor. And then, number 3 is to set up the equation. So, yung equation natin, doon natin usually makukuha sa variable. Any equation na mag-represent sa atin sa variable na hinaharap natin, then that will be our working equation. And in this case, I'll be using the distance formula because we're concerned with the distance or the nearest point. And diba, to do that, we need to identify it as a distance. So in this case, we have the distance equal to, and I know you already know the distance formula, so basically that's just d is equal to x sub 1 minus x sub 2 and then squared plus y sub 1 minus y sub 2 squared. So, ito yung ating distance formula. Now, can x sub 1 and x sub 2 be interchanged? That's okay because mas square lang naman to. But, remember, the operation should always be minus in between them. Okay, and then plus dito sa pagitan mismo ng dalawang ini-square natin. Okay, so, wag malilito doon. X sub 2 and x sub 1 can actually be interchanged. But, to make sure that you stick with the rule, kung x sub 1 ang inuna, dapat y sub 1 pa rin dito. Kung x sub 2 dito, then y sub 2 right here. Okay, so we proceed with the computation. So, ano ba yung x sub 1 natin? Ano ba yung x sub 2? So, in this case, if I represent this x dito sa atin as x sub 1, and then this y is y sub 1, I can now also say na ito yung ating x sub 2, and then this is our y sub 2. So, therefore, I can now write it here na, so ito yung number 1 natin na ginawa, which is nag-plot tayo, nag-graph, and then yung number 2 natin is yung constraints, pero yung constraints naman is actually ito na yun. So yung number 3 is ito yung last portion natin ng solution. So the working equation will be d is equal to x sub 1 minus x sub 2 and then plus y sub 1 minus y sub 2. So if this is x sub 1, then I'll just have to write x. And then in this one, that's minus negative 1. So that's plus 1 squared. And then this is y. So y and then minus 1 squared. Okay. So this is our general equation as well. And then it is also said in your handout or module na kailangan natin siyang i-represent in terms of one variable dito. Kasi kung mapapansin nyo, meron tayong dalawa. One is x, so ito yung x natin, and then yung isa is y. So we need to find an equation that represents this y in terms of x, because if we do that, then we can solve for our critical or our maxima or minima or whatever, whichever is applicable. So in this case, ano ba yung equation na pwede nating makuha na magre-represent ng ating y in terms of f of x? And then, if that's the case, ang sunod na step is to look at the restrictions or the constraints. Diba sabi ko before, the constraint is the parabola itself. So in this case, you can see here, x squared minus 3x plus y equals 7. So for every x value on the parabola, there is a y coordinate for that. And that y is represented by this equation, the original equation. So from this, we can also say that y is also equal to 7 minus x squared plus 3x, because for every x, you have this kind of value of y. So in that case, I'll be substituting that with the equation from our parabola. So d is equal to the square root of x plus 1 squared and then plus. So we have y. So y is represented in terms of x. So that's 7 minus x squared plus 3x. And then proceed with minus 1. Okay, so that's it. So I hope nakita nyo siya ng malinaw dito sa ating solution. So yung red part dyan is kinuha natin sa original equation, which is our limiting factor or parameter or constraint natin dito sa equation na to. Okay, so with that, mayroon na tayong lahat ng x. And ano ba yung sunod natin na step? Okay, so the next step would be that is to differentiate that. Kung meron ka ng equation na na-produce na lahat na lang is in terms of one variable. So we can now differentiate, but before that, to simplify your differentiation, there are many pathways that you can do. First, you can always simplify the expression first, and it's all up to you. Okay? So pwedeng mag-simplify muna kayo, pwede namang hindi. So in this case, I'll be simplifying a little inside, okay? Because meron ditong constant 7 minus 1. So I could just make it, let's say, 6. And then ito, and then square. Now, for others, they would expand this and then expand this trinomial and then cancel out this necessary variables kung meron man, and then you will have a lot of terms for them to easily differentiate the function. But for this case, I won't be doing that kasi in the end naman is mag-differentiate lang naman tayo, so we don't have to do it anymore. So I'll proceed with differentiation. So differentiate. So when I differentiate, I would have a d prime. So of course, this is with respect to x. So d prime is equal to 1/2, because that's power rule. Kasi ito yung raised to, yung whole equation is raised to 1/2. So 1/2, and then we have x plus 1 squared. So kakapahin ko lang muna yung nasa loob, and then 6 minus x squared plus 3x, and then that's squared, and then we raise this to negative 1/2, and then we multiply this with the derivative of what's inside. So that's 2, and then we have x plus 1, okay, and then plus 2, and then 6 minus x squared plus 3x, and then that's multiplied with negative 2x plus 3, okay, and then we can rewrite this. Lalagay ko lang lahat ng mga negative exponents sa baba, and I'll be leaving yung mga positive sa taas. So we have 2, and then times x plus 1, then plus 2 times 6 minus x squared plus 3x, and then negative 2x plus 3, and then we divide all of these by 2, and then x plus 1 squared plus 6 minus x squared plus 3x squared raised to 1 half. Okay, so we're pretty much done with our derivative. And the next step is that we equate that to 0. So, bakit nga ba natin i-equate siya sa 0? So, remember, kaya nauna yung topic na extreme of a function kasi by equating the derivative to 0, we can determine the critical points. And if we're able to solve for x, in this case, by equating that to 0, then yun yung ating critical point. Doon natin ngayon kukunin kung ano ba yung magiging value ng x that will produce the minimum or the maximum value of the distance. So, we equate this to 0. So, I'll just copy this one and then equate this to 0. Tinamad na sa pagkopya. So, that's equal to 0. And then, we know very well na itong denominator na to is makakancel lang. Maging mamumultiply kasi siya dito. So, matitira lang sa atin is yung ating numerator. So, we're left with our numerator right here. Okay? So, kung meron kayong confusion kung ba't numerator na lang natira, so, basic naman itong process na to. So, multiply both sides by the denominator and then you'll get this 1. Okay? So, mula dito, you can either press your calculator and shift solve for x. And you can also skip for that and then try to simplify first. But for now, I'll be simplifying muna. Kasi I will like to show you something. Okay, so that's 2x plus 2 and then plus, I think that will be 12 minus 2x squared plus 6x. And then we have negative 2x plus 3 is equal to 0. And then we have 2x plus 2 plus negative 24x plus 4x cubed minus 12x plus 36 and then minus 6x squared plus 18 is equal to 0. So we combine like terms and we'll end up with 4x cubed and then I think this should be 12x squared. Okay, so with that we end up with negative 18x squared and then 24, so that's, and then this one is 18x, so minus 4x and then plus 2 plus 36, so that's 38, I think. Okay, so that is equal to 0. Okay, so now if you'll be using the shift solve function, then you will know na you will be able to get one answer for this kasi if you'll be using the shift solve, then you can always try to use the negative, positive, or the high value for the memory. Syempre, pwede naman yun. But if you would do this, yung simplifying and knowing na cube naman yung highest, so you can do that and then you can use your function for yung ating solve function. Okay, so you can always use your shift solve and then use the memory, negative, positive, and a high value. But for now, I think it is best to use this 5 equation and then yung ating 4, ito number 4, since kung mapansin niya, this is in cube. So in this way, mas madali kung makikita yung roots without using the Rene Descartes rule of sign and then trying doing trial and error just to get the correct memory for my calculator. So ayan. And then, yan, binigyan niya ako ng values for x. So, x sub 1. So, yung unang x natin daw is negative 1.361. 13. Okay? So, syempre, that's approximately equal lang. And then, we also have, so press equals lang ulit. So, we have 4.1994. So, we have 4.1994 and then I think meron pa tayong isa kasi cube root to. Cube. So, we have 1.6618. Okay, so these are our 3 critical points. And then, remember what we did dun sa ating extrema of a function is we need to check this on the number line. But there is one way to check on this without doing that number line. Because we know that we need to find the nearest point at the parabola, we can just substitute that to our distance. This is the formula right here. And then whichever would give us the smallest value, then of course, in common sense, that's the shortest distance. So let's just do that to avoid yung paggawa pa ng number line, because that's the fastest way to solve for this, no? So using that, the distance would give us a value of so I'll be typing this equation right now. So I have the square root of x plus 1 squared, and then plus 7 minus x squared, then plus 3x. So it should be 6 na lang pala, but ayaw mo na, nasulat ko na eh. That's squared. And then we press calc, ibig sabihin calculate natin kung ano yung value, and then we substitute all of these critical values. So we have point. So 1.3613. Okay, so the distance is 0.3667. So with this, that's 0.3667. Okay, and then let's look at 4.1994. So press calc and then 4.1994. So syempre, mas accurate yan kung in-store natin yung values, pero hindi ko na na-store, so yan na lang. So 5.2879. And then finally, for our D, so comparing these two x's, mas maliit to, diba? Pero syempre, kailangan natin check yung last. So again, press calc for the last. So that's 1.6618, and then the answer is 8.6439. So 8.6439. Okay, so comparing all of these distances, so we know for sure that this is the correct answer for our problem, but that's just the value of x. In this problem, we need to actually find the point that is nearest to the parabola. So we're not yet done. We need to find y. So y is just basically equal to 7. So I think that's already stated here. We have 7 minus x squared plus 3x. So that's 7 minus x squared plus 3x. So with that, so let's substitute for the value. So what we'll be getting is, so that's 1.0630. Syempre, this is rounded off. So the value that is nearest, so you can just write for the answer that the nearest point from negative 1 from the parabola to negative 1, 1 is this x and y. So that's negative 1.3613, 1.0630. Okay, so that's the answer. Okay, so hindi ito yung sagot because that's the distance. We're looking actually for the point in the parabola. So this is the answer. Okay, so one way to check also if your answer in this critical point is correct is to check the second derivative. So kung tatatandaan nyo before, diba, we can always check on the second derivative, and so if the critical value gives you, let's say for example, a negative value, then that's the maximum, and if it's the positive value, then that's the minimum. So in this case, we're looking for the positive value because we're looking for the minimum, because that's the shortest. So shortest, smallest, so those adjectives would lead us to the idea that it's the minimum. So in this case, I'll be going back to the calculator, and then I'll try to check on the second derivative for this. So to simplify the computations, because these are just checking, we can always use the derivative function of this calculator for checking values, no? Kasi we couldn't use that when we're finding the derivative because the calculator doesn't give you any value for the derivative or the exact expression of the derivative. But if you're substituting values, you can always use this function that we have here. So I have this expression. I'll copy it just how you see it, and then let's try to check on the values if it will really give the correct answers. So that's times. Okay, so I've just written the equation, and then I'll be substituting these critical values, and hopefully I could get what I need. So to give you some suspense, I'll be starting with this muna. Okay, so that's 4.1994. Okay, so that's 5.3368. So this one is this one gave me a positive value. So the second derivative for this one gave me a positive value. Okay, so for this one, we check on that. So we substitute the value for this. So that's 1.6618. Okay, so this one gave me a negative value. So this x gave me a negative value, but let's check on the last, which is our answer. So this should give me a positive value. So that's negative 1.3613. Okay, so that's the positive value. Okay, so in this case, ano ba yung pipiliin mo since pareha siyang positive? So I don't think I have mentioned about this, but since the value here is negative, kung mapapansin nyo, that's negative 1.3613, and then the second derivative is positive, so you'll be choosing that because that is the maximum. Because in the case wherein your x is positive, so makita nyo this one is positive, and then even though this one is positive, then because that is supposedly be the maximum, but they have the same sign, so basically hindi na siya yung ating pipiliin kasi hindi siya actually yung maximum natin. Probably it could have been, or minimum, sorry, probably it could have been some point, right? Let's say for example a critical a stationary point wherein that's an inflection point, or it could be that it is a saddle point. So there are cases wherein it could be like that, but you need to look at the sign of your x, and then you look at the sign of the second derivative. If it's opposite and it started with the negative and then it becomes positive, then it should be the minimum. And then if it's positive and then it becomes negative, then that should be the maximum. So if you'll be plotting for those points right here in the graph, so that's 1.6618, so it's around here, 1.6188, and then I would think that the point should be around the vertex. Okay, and then for the other one, that's negative 1 point something, so that's 1.363. It's around, I think it's just around here. So basically that's actually the point that we're looking for. And then we know that for this value 4.1994, so that's 1, 2, 3, 4, so it's typically around here, I think. 1, 2, 3, 4, so maybe it's around here. So yun. And then we know this distance that we have here is basically the maximum distance in this case, and then this one is the minimum. Kaya importante na malaman natin yung ating second derivative test or this test dependent sa equation, because you might be selecting the wrong one. Probably baka naisip nyo, oh sige, ito na lang, positive kasi positive yung sagot niya. But the idea is that you check on the criterion that is presented in the problem. Okay, so yun lang for this example number 1. And let's proceed to example number 2.